Okay, so not everybody's here today, but those who are did extremely well with this. So that's very good. Thumbs up. I'm getting more optimistic. And I was already pretty optimistic about how this group is going to do. Okay. So we want to solve this problem or this equation where f of x is the square root, the toolkit square root function. And a, h, k, and d have these values that I don't need to read to you because you can see them. Okay, you prove that by writing them down correctly. Now, and they're even clearer, I think, on video. Okay, well, so what is our equation? Well, first of all, I would start by just making sure I get f of x minus h correct. Okay. And if I thinking, which is always questionable, that's going to be sloppy. Hang on a minute. Anyhow, I think we'll be able to read it. I'd like to split it. Okay. First of all, the toolkit scaling function is f of x equals square root of x. So that f of x minus h is what? Now, again, if you're watching the video, don't just wait for me to tell you, figure it out. Stop and write it down. If it takes you more than 30 seconds to write it down, then maybe you need the explanation. Otherwise, exercise your brain. Don't sit there just waiting to see the answer. And of course, you're going to recognize it, and then you're going to think you understand it. And probably you do, but test yourself, write the blame thing out. Okay, so x is being replaced by x minus h, so we replace x by x minus h. I've done that and pointed to that and said that 150,000 times this semester. It seems that way, and you're probably getting tired of hearing it. But some people still need to hear it. So if you do, there it is. Now, okay, there we have f of x equals square root of x minus h is the square root of x minus h. Well, the rest of it is really easy, so that a f of x minus h plus k equals d becomes a times the square root of x minus h plus k equals d. And as we did in class, in the pre-calculus class last time, we just subtract k from both sides, divide both sides by a, and then we have the square root of x minus h. We square both sides, and there it is. Now, since everybody here did that already, I'm preaching to the choir, but of course, I'm also preaching to those who aren't here, who would have, I think, done this correctly themselves. Okay. And anybody else in the class who might still be confused, because of course these videos are easily available to anybody with a link to the general page. Okay, so here we have. Now, we can then replace a, h, k, and d with the numbers, so we get minus 3. But this is multiplied. A is multiplied by this. That was one point of concern from some of the students here today, that I think maybe there's a tendency to confuse the number out in front of the radical with a number that goes inside this radical, like a cube root or a fourth root or something like that, or a negative third root. Okay. And that's not what it is. It's a multiplication. This is multiplied by this. Okay. I didn't indicate the multiplication, but we know it's multiplied because it's multiplied here, right? In the original form, A is multiplied by F. Okay. So we get negative 3 times the square root of x minus, what's h? 5 plus k, which is 12, equals d, which is 6. Okay, now we write the equation up here, and then we can solve it. Okay. One thing that some people might want to do here, and it wouldn't be a bad step, but it's not necessary at all, is since we have a negative in front of a thing that has X in it, multiply everything by negative. Okay, that's okay. It's not a bad idea, but it's totally unnecessary and I'm not going to do it. But if you did that, that would be okay. So if you're thinking in your taste leads you to want to do that, please do. Just do it carefully. Multiply the whole side, each side by the -1, and you change all the sides. Now, and I'm glad you're here. Glad to have you. And I know you would have done this right too. So we're just, what we're doing is we're solving this equation, which we saw in class last time. Okay. We're solving this equation for X, where f of X is a toolkit square root function. And A, H, K, and D have the given values. So we do the substitution down here and we get this equation. So we're just ready to start solving this equation. And the comment I just made is we can multiply both sides of the equation by -1 if we wanted to. It's not necessary, but if we want to have a positive sign here for some reason, as long as we change the signs of both of these things, we'd be okay. So I'm not going to do that. We're just going to proceed. Now, what's the first thing I would almost certainly think to do? I've got a plus 12 in this and a 6. And we're trying to get to X. So it's real easy to get rid of that 12, subtract 12 from both sides. I'll write this. And I really prefer that you write it like this, where it's explicit that we're subtracting 12 from both sides. People have different notations. They'll put a -12 here and a -12 here. And as long as they add them, that's okay. I prefer equal sign between the -12s if you do that. Some people throw a -12 up here and a -12 up here and cross things out. We still get the right thing. And as long as you get the right thing, it's kind of okay, but you're reinforcing the operation if you write it like this. We know that we can subtract 12 from both sides. So you really want to remember that. And if you're thinking that when you do this, okay. If you're not thinking that when you do this, you're going to be a little more likely to screw it up at some point, okay? But it's okay. As long as it works, as long as I see what you're doing. Okay, I want to see every step. Okay, so we have -3 times the square root of X minus 5. Well, that's a lot simpler. Now we still have to get to that X. What else is in the way over here? Well, X is bound up inside the square root. So we're not going to try to get rid of the -5. Some people try to add 5 to both sides, but that 5 is radical and tied up with X. You can't do that. Okay, but the -3 is multiplied by this. And when something is multiplied by something else, you can divide it and get rid of that thing. Divide it on both sides, of course, because otherwise your equation becomes unbalanced. You have -3 times the square root of X minus 5 divided by -3 equals -6 divided by -3. So now you have the square root of X minus 5 equals 2. And what do you do there? Well, everybody knew this step. You square both sides. Because if you square a square root, you get whatever's underneath it. Okay, that's somebody's giving me hand signals here telling me that I've done something ignorant. And that's quite possible that I have. But let's just pause a second and see what the question. Okay, it turns out somebody's been paying too much attention to the ignorant errors I make and made a similar error. In your case, it's not an ignorant error, just a careless error. If I do it, it's ignorant. Okay, and careless. Okay, and I do it. Okay, so anyhow, yeah, we get 2 here, and somebody wants to put 3 here because you kind of got 3 in your mind after you've written out all these divided by -3s. Okay, but 6 divided by 3 is 2, and the negatives give us a positive. Okay, that's good. So I'm gonna write it out. I'm not just gonna take away the square root sign. I'm gonna write out the step. Okay, and not everybody wanted to write out this step, but we want to be very explicit so that we reinforce what we're doing instead of just doing it out of habit and forgetting that it's a basic rule. Okay, so when we square a square root, we get that thing we took the square root of. We get x minus 5 equals 4. Then, just to be complete, we'll add 4 to both sides, and we get, see what I just did? That was ignorant, it wasn't just careless, it was both. Why would I add 4 to both sides? I'm trying to get rid of that 5. Okay? Because my eye picked up that 4 and my brain didn't register what I should have done. It registered what my eye saw. Got to be careful about those things. It wasn't going to work. When I said -5 plus 4, I said, well, that's going to be -1. I don't want anything over here. I want to just get x. And x equals 9. I was already thinking ahead to x equals 9 and checking it. Okay. Well, you should be able to then substitute x equals 9 back here. If you do, you get 9 minus 5. What's 9 minus 5? Show me with your fingers. Just make sure you're with me. And what's the square root of that? Yeah. And what's -3 times that? Well, this is 2. -3 times 2 is -6. Yeah. Okay. And you add -6 to 12. What do you get? -6 and 12. That's like 12 minus 6 gives you 6, right? Okay. So you can check that one in your head, or you can just scratch it off to the side. Again, if you get it wrong and don't check it, it's going to cost you more points than if you just get it wrong and don't check it. Get it wrong, acknowledge that you screwed it up. Say either I don't have time to do this because I've been sitting here in this test for 6 hours and I got to go to the bathroom, or whatever, or I'm about to faint from hunger. You know, that's always possible. Because I don't put a time limit on the test, and I'm not being sadistic by that. I want to see what you can do, but you know, try to do it efficiently for your own sake. Okay. So, point is, you can say, I don't have time. I know it's wrong. Have mercy. Okay. Say, I know I should check, but I can't take the time right now. You know, whatever you want to say. Acknowledge that you know you're supposed to check it, but you didn't, and you're pretty sure it's right. If it's wrong, then probably only take off half as many points as I would, depending on what mistake you made. Okay. Okay, so does that make sense? Okay. So the process is very simple again. If you look at the symbols again, what did we do? We subtracted this thing that's added from both sides. You should be able to do this with the symbols. I might even give you the opportunity to do a couple of those with the symbols. Okay, because it's important to be able to do that. So we subtract k from both sides, and then we divide both sides by a. And then we square both sides. Now, I think I did that in class. Okay, with the symbols. I'm not sure I did it with all the functions. I don't remember. But then again, there's another video tacked on. I think there are 3 videos associated with last time's class, where I wrote down 4 of these things and did them with the numbers, just like we're doing here. Okay, but just to be sure you have plenty of examples. I've written down 3 more. It's not every possible case. Okay, well, the question was on the test, will it be phrased like we phrased this? I think, you know, the phrasing's over there now, but we have the same phrasing with, you know, a equals this, h equals this, and it's a f of x minus h plus k. I would expect to be able to do it with slightly different phrasing. For example, I think, and this is a little more than what I answered when you asked the question. I could tell you, we got a vertical stretch of so much horizontal shift and a vertical shift. You should know that that's vertical stretch, that's a horizontal shift, and that's a vertical shift, so you should be able to write this down. And, you know, where that function is equal to some number, okay? Or I could say, write down the form of the equation. If f of x is given a horizontal shift, a vertical shift, and a vertical stretch, and set equal to this number. Okay, does that make sense? Could you handle that? Yeah, well, I'll try to. Yeah, I'm going to give you some problems over the weekend. Okay, because you know, people have a way of putting off review until like 10 minutes before the test. You get tied up with other things during finals week, and it just happens. You should have better planning than that. You know, I didn't always have better planning than that. I usually did because I was usually fairly paranoid. Okay, often for good reason. Okay, so anyhow, okay, here we go. Now let's just do a couple more equations just to show. I'm going to do these quickly. I'm not going to stop and do a lot of explaining because the steps are almost identical to the steps here. This one is the same as that one, but my function is the fundamental scoring function, right? So you should be able to recognize this. If I give you this form and ask you what's the function, you should be able to tell me. And if I give you this form or this equation, you should be able to construct the graph by transformations. We've spent a lot of time on that. And you're going to see that problems that I set out this weekend. Okay, so here we have it. Let's just do it. Now, what are we going to do? That 6 is sitting there just waiting to be plucked off, right? Because it's added to everything else. So we do -3 times x minus 5 quantity squared plus 6 minus 6 equals 12 minus 6. Looks a lot like what we did here, except that this is squared. Well, that gives us -3 times x minus 5 quantity squared equals 6, -6. And I think I've got the 6 and the 12 mixed up. Got them reversed. So let's just try to fix that much. Oh man, that water's getting pretty murky, isn't it? I think I can get that go away. Kind of dry. A little drier so I can write on it. Okay. So that should be plus 12 equals 6. So it's plus 12 minus 12 equals 6 minus 12. So we get -6. And identical steps to what we did before. We get x minus 5 quantity squared. Well, let's write it out. Okay, I don't have to tell you what I just did. I divided both sides by -3. Take one of that -3 out of there. You get x minus 5 squared equals 2. This splits into two equations. X minus 5 equals 2. X minus 5 square root of 2 equals negative square root of 2. Okay. And you can write that as x minus 5 equals plus or minus the square root of 2. But I want you to understand that many equations split into two or more equations, like with a polynomial equation. Polynomial is equal to 0, then every factor has to be equal to 0. Okay. If you got an absolute value, you get two solutions. And there's an epidemic of people just ignoring the absolute value signs, just taking them away and solving one equation. You can't do that. Okay. So anyhow. X equals square root of 2 plus 5. Usually we put that in the reverse order. 5 plus the square root of 2 but it's not incorrect to say it ungrammatically. Okay, so we have here, same thing. And that's the order it should be in, but the square root of 2 is negative. So that's it. There's nothing there that's unfamiliar to you. You just got to remember that it could be plus or minus the square root of this. And if this thing's negative, if this was a negative 2, then the square root of negative 2 would be square root of 2 times I. Okay. So we got to be aware of that. Remember the assignment of complex numbers. Okay, if you did every step right, but missed that I, well, it'd be a little more penalty than if you just, accidentally reverse your 6 and your 12 or something like that. But it wouldn't, you'd still have more than half credit if you did everything right. Okay, so in this case, we have the X in the denominator, and we have a denominator. And I say, wipe out the denominators before you do anything else. Now, it would be okay, and I've got the 6 and the 12 reversed in all of these, haven't I? Hang on. I want to make these solutions as close to, where's the what part of this now? As close to close to the solution here as possible, so you can see the differences. Okay, so it should be plus 12. And of course, this problem would not have had a solution if I'd had these things reversed. So, okay, so what I say is it wouldn't hurt to subtract the 12 from both sides here and then multiply by the denominators. So if you were inclined to do that, it would be okay, but I'm just kind of advocating an automatic response, which is where you multiply both sides by a common denominator. There's only one denominator. So we're going to have x minus 5 squared over 1 multiplied by negative 3 over x minus 5 squared plus 12 equals x minus 5 quantity squared times 6. Okay. Now I've multiplied x minus 5 squared by both sides. Now, this is going to give us and I'm writing a square root instead of a square. I swear I got a good night's sleep last night and I'm feeling pretty alert. But apparently that's an illusion. Okay. Now I haven't written out the details, but I've squared x minus 5. Do that as x minus 5 times x minus 5. Don't do that as x squared plus 25, which would be totally wrong. Squaring does not distribute over subtraction or addition, right? Distributive law. Okay, now there's a standard form of square of a binomial. If you write out that standard form, which would be quantity a plus b squared equals a squared plus 2ab plus b squared, and show me that you know that and substitute, that's okay too. But if you write x squared plus 25, you're probably going to lose half credit right there. Okay, that's really a big one. Okay, so anyhow, if we have that, well, here we get -3. Here we get 12 times x squared minus 10x plus 25 equals 6x squared minus 1060x. I'll do what I just did. And just look at this and forget to multiply it by 12. And 12 times 12 times 10 is, as you probably suspect, it's not 60, it's 120. Okay. And 12 times 25 is 300. Okay, well, this is getting to be fun, but it's really pretty simple what comes out of this. We have -3 plus 12x squared minus 10x minus maybe I didn't sleep as well as I thought I did last night. Okay, multiplying here by 12. But I should have been multiplying by 6. So my 60 was correct in the first place. You want to check yourself as you go along. You don't want to get too far ahead. Yeah. Okay. And the thing that alerted me to this is that, wait, I have a 12x squared here and a 12x squared here. The x squared is going to go away. We can't do that. Okay. So here's this step. Sorry, it's getting, I'm writing a little small here. All we're doing is we've expanded the x minus 5 here and here, and now we're just multiplying through by 6 and by 12. Okay. And then this equals 6x squared minus 60x plus 150. We're gonna have to borrow a little space from this problem, except I can do it from here and here. I can get this problem done here. Okay. I'm not going to go through all the details. And if you need to look at this in the video, it's okay. Because I really can't slow down or write this any bigger because we have other things we need to do. Okay. But, you know, I've got an x squared here and an x squared here. What kind of an equation is this going to give me? I'm going to give you the opportunity to show off. What kind of an equation is this? Okay, well, somebody told me it was an exponential equation. I was getting a little worried about them, but they were looking at this one. Okay, and they were right. Okay, as I expected, because that was from somebody that usually knows what they're talking about. Okay, now, then we asked, what about this one here? Well, there's just one we're still working on, okay? And so somebody quickly identified that as a quadratic equation. It's quadratic. It's got x squareds, it's got x's, and it's got numbers. It's got x's on both sides. It's got x squareds on both sides. It's got numbers all over the place. Okay. But we can put this in the standard form of a quadratic. Okay. So we want to put that in the ax squared plus bx plus c equals 0 form, so we can use the quadratic formula. And maybe we could even factor it, but I doubt that. Okay, so we get, and take my word for it, but you can do this. Okay, it seems ridiculous. 6 times 147, though, is in the low thousands. Okay, that's not even 1,000. And 60 squared is 3,600. So 4 times AC is going to be less than B squared, just looking at it. And looking at the equation, I can see that there has to be a solution. Okay. Just that X has to be pretty close to 5 to make this big enough, a big enough negative to bring 12 down to 6. Now, if you understand that, great. If you don't understand it, just plug on through, because I'll just put in et cetera, and then X equals 60 plus or minus the square root of 3,600 minus, okay, 6 times 140 is 840. Yeah, and 6 times 7 is that, so it's that. Okay, 840 times 4 is 3,360. And then 6 times 7 is 42, and 4 times that is 168. Maybe that's 3,608, big question mark there. That's done in my head. And that's over 2 times 6. Okay. Now, 2 times 6 is 12 divided into 60 is going to give me 5. So X is going to be close to 5. It's only going to differ from 5 by this square root, which would be divided by 12. And that square root is like, oops, if I did that right, got to be a real solution to this. I'm sorry, but it will have a real solution. Okay, something's wrong with my calculation, because I'm pretty sure this number is going to be less than 3,600, but it's going to be kind of a small number. So you worry about that. So if you understand what I'm talking about, you know, okay, but otherwise just plug on through. Now let's see. We've got 840 times 4, which is 3,200 and 3,360. It should be 3,408, not 3,608, I think. So that kind of fixes it. Okay. Still doesn't satisfy me, but that doesn't matter. Okay. You see what the steps are, and that's what you really need to do. All right. If you understand my speculations, that's even better. But if you don't, just ignore them. This is how it's solved. Okay. And I'm getting something like close to 6 and close to 4. Which give me like 1. Gotta be less than that. Okay. Let's move on to this. Okay, this one is solved very similarly to the way this one or this one is solved. This one's a little different because we have that denominator. And the steps are somewhat different than they are these other equations. Okay, well, we have a little difference here because we have to use logs because X is in the exponent. We know that's coming up because of what we've learned so far, but we just do. Now, I'm not writing out every step. I subtract 12 from both sides to get -6. And then I divide by -3 and I get 2. For the same reason, I got 2 here and here. Okay, exactly the same steps. So I haven't written them all out, but you should. And at this point, we just change this to logarithmic form. And we get X minus 5 equals log base 2 of 2. Then it turns out, you know what the log base 2 of 2 is. You shouldn't have to go to your calculator to do that. But if you did, you would do log of 2 over log of 2. Okay? So you get x equals 6. So that came out very easily. And that was just an accident that we came out with 2 here. We know what the log base 2 of 2 is. If this number was 7, then I'd have had a -5 here and -5/3 here, and you'd have had to use your calculator to calculate the log. But the point is, you just do the arithmetic to where you got 2 raised to a power equals a number, and that's the form that you can convert to exponential, a logarithmic form, okay? And you do that conversion. Or Open Math has showed you how to take the log of both sides of an equation, and that's also valid. Then we have a quick question. Boy, that was quick. Okay, the question came up, shown there. It's a little something you need to be reminded of. Okay. We're using the fact that b to the a equals c is equivalent to log base b of c equals a. That's the inverse function equivalence. And you might want to review where that comes from. Just comes from the fact that you're reversing columns of the table, or that you're reversing the coordinates of points on the graph of the exponential function to get the graph of the logarithmic function. Okay, and we're not going to take time right now to develop that. I can maybe review that next week if we need to, because you do need to understand inverse functions. So I'll kind of throw that away. Okay, but there's your equivalence. And you really want to be equipped with this. You want to remember this. Okay. So using this fact, you identify that for this problem, when we get down to here, a is x minus 5, c is 2, and b is 2. Here's your b, here's your a, here's your c. So when we write log base b, we write log base 2. And then c is this 2, so we put in 2 here. And that equals a, which is x minus 5. So that's how we get from this form to this form. Make sure you're very aware of how to change the form from exponential to log or log to exponential, because you are going to see that probably more than once on the final. Okay. Does that answer your question? Okay. And then, of course, you could take log of both sides, and that's legal if you remember how to do that from Open Math, if you like that better. But I really want you to understand this, because this really emphasizes the inverse function nature. Okay. Well, I sure wish we had a little more time so I could do the Sane-Demented model. We're toward the near part of finals, and okay, I'm going to do it anyway. Okay. People who are sane tend to become a little bit demented during the finals. Would you agree? Okay. And people who are demented maybe focus and become a little bit sane sometimes. Okay. So let's just say that among this population, we have .500 people who are sane and 500 people who are demented. Okay. And demented, you know, dementia is something you tend to apply to people my age, okay? But demented has a broader definition than just dementia, okay? Dementia is a form of basically losing your mind, okay? And, you know, that happens, you know, people get Alzheimer's, and people get too old, okay, they tend to lose stuff, okay? So that's something you don't want to happen. You don't want it to happen to people in your family. You don't want it to happen to anybody. It's inevitable almost with age to get old enough. It's a penalty for living long enough. So it's unfortunate, but that's the way it is. The broader term is, you know, nuts. Okay. And, you know, demented can be people that go out and, you know, commit terrible crimes, or just people who really can't function in society and need to somehow be restrained because they're either dangerous or disruptive. Okay. Anyhow, so that's a general. So if we're talking about the student population, we're only talking about very mildly demented, just people that just get a little bit off during finals, right? Not dangerously so, and so forth. Okay, so it's just kind of a humorous term, okay, for things that happen to people. So we're going to say harmlessly demented. Okay. Okay, so I'm going to use big D and big S for sane and demented. Okay. So 20% of the demented become sane. So how many of the sane people are going to become demented? You show with your fingers. That's 10. 10%. How many is that? 10% of the number of sane. There are 500 sane, right? What's 10% of 500? Yeah, 50. Okay, everybody knows that, I think, I hope, even though more people don't know that because of the use of calculators and also relative emphasis in math curricula on a limited number of topics due to COVID over the last few years. Okay, so you got 500. Okay, this will be number of sane people, and 500 your number of demented people, right? So you have 50 sane people becoming demented. How many demented people become sane? It's 20% of 500. What's 20% of 500? Give you a hint. It's twice as big as 10% of 500. 20% is twice as big as 10%, right? So 10% of 500 is 50. What's 20% of 500? Yeah, it's 100. Now you really should be able to do these fairly simple calculations in your head. You should be able to see 20% is like 1/5, right? 20 out of 100 is 1 out of 5. And 1 out of 5 out of 500 is 100. Well, you're not going to solve that, which in a week, so we'll just go on, because you can always use a calculator, but you want to see it with easy numbers. Okay, well, how many sane are we then going to have? Are we going to increase or decrease the number of sane people? It's going to increase the number of sane people. You're going to lose 50, but you're going to gain 100. right? So yeah, if you look at this, you say, well, it's going to decrease, but if you look at the whole picture, it's going to increase. So you're going to have 550 sane, and how many demented? Well, you're going to lose demented, right? Because you're going to lose 100, but only gain 50, meaning you're going to lose 50. So that's going to give you 450. Okay. Well, that's just before your first final exam. Your next final exam, same thing's going to happen to you or to our population. Now you notice that our population is tending toward the same because we're losing fewer sane people than we're gaining from demented, right? And we're losing more demented than we're gaining sane. So this is good. Okay. So we've got 550 here. Okay, well, we can do this again. What's 10% of 550? It's more than that. It's more than 51 or 52. 10% is like dividing by 10, right? Divide 550 by 10, you get 55. Okay, so you get 55 here. And you get 45 here. No, you get 90. I'm sorry. I tried to do 10%, but hung up. Okay. So, well, if you gain 55, or let's say you lose 55 and you gain 90, well, the difference is 45. So that puts you, difference is 35. That puts you at 585 and 415. Okay. And maybe you got a third final. Well, then you're going to lose 58.5 here, and you're going to gain sorry. Yeah, that's right, 58.5. And you're going to gain, I'm getting an even number. It can't be right. I'm getting 83 here because I apparently can't do arithmetic, but 415 times 2. Well, we'll put an et cetera down there because we're not going to calculate it anyway because we're getting into decimals. Okay. Well, that's all good, but so that's what happens. Now, let me show you an easy way of doing this. Okay. And don't worry if the numbers are wrong because we're not going to use them. This is a row. This is a column. To multiply a row by a column, you multiply the first number in the row by the first number in the column, and the second number in the row by the second number in the column, and then add them. Okay, so in this case, this would be 0.9 times 500 plus 0.2 times 500. If you calculate that, you get 450 plus 100, which is 550, which is the number of sane that you're going to end up with. Okay? Now, we don't have time to let you actually do this because I want to demonstrate it. Point 1, 0.8 times 500, 500 is what? It's 0.1 times 500 plus 0.8 times 500. That's an easy pattern, right? If I had a row of 10 numbers, well, then I'd need a column of 10 numbers, but then I could match them up, multiply them, and then add up the results, right? That'd be very easy. So it'd take a little longer, but I could have any length of row and any length of column, and I could follow this rule. Okay? Well, this gives me 450, because 0.1 times 500 is 50, and 0.8 times 500 is 400. 400 and 450. There's 50, 450. I mean, 400 plus 50 is 450. That's 50, that's 400. We get 450. Okay? So got that? Now, I haven't told you where these numbers come from. But I'm about to. Except I want to put them all into one calculation. So I'm going to do this. I'm going to say, okay, I'm going to take my first row, 0.9, 0.2, and my second row, 0.1, 0.8, and multiply that by 500, 500. Okay? So what I do is I multiply 0.9 by 500. I multiply this row by this column. Okay? So I get 0.9 times 500 plus 0.1 times 500. Okay, this is the first row. Times our column. Then 1.8 times 500, 500. And there it is. Okay. Now, of course, I've already done these calculations, but you know, if I hadn't, they're very easy to do. You can use your calculator because you're going to need it. If you then keep multiplying by this matrix, the numbers are going to get more complicated. But we haven't done that just yet. When we start calculating these numbers with the matrix, there's our second row times the second column. Okay. So everything just lines up. It's very logical, very easy to see. Just got to get used to it. Okay. Now, if I was to multiply this by 550, 450, following the same rule, I'm not going to write it all out, but I'm going to end up with my 585 in my 450. I just follow the rule. Yeah, 0.9 times this, okay, and 0.2 times this. Then if I multiply the same matrix times this, I get the numbers I should have gotten here, and I don't know what I did wrong. Because I'm getting a decimal over here, no decimal over there, because I'm just doing it wrong in my head. Okay. I'm still getting like 83.0 there and 58.5 here, and I got that stuck in my head and I can't get it out. Something's wrong with my head. I mean, I'm getting a little bit of this, you know. Okay. Hopefully harmlessly, as long as I'm not confusing you, it's harmless. All right. Okay. This thing here is called the transition matrix. It takes the transition every time you have an exam, every time people have an exam, the demented people tend to get a little more sane because they're under pressure, but some of the sane people just become a little bit demented because of the pressure. Okay, depends on how people react to the pressure. All right, so there it is. And it's a very simple scheme. Now, we take the scheme one step further. What do we mean by 0.9, 0.2, 0.1, 0.8 squared? What could that possibly mean? Well, one thing it doesn't mean is square this, square this, square this, and square this. Any more than x plus y, quantity squared, would be x squared plus y squared. Squaring doesn't distribute over addition. It doesn't distribute over the components of a matrix, okay? What this means, anybody want to tell me what it means? What do you do to square something? Okay, to square something is you multiply it by itself. So that would be okay. Now we've got row one, we've got column one, right? I'm sorry, we've got row one and row two. We've got column one and column two. Fair enough? How many different ways could you multiply a row by a column? Well, I don't know. There were two ways to multiply a row by a column up here. First row times the one column we have, second row times the column, right? So what row would you be able to multiply by what column? Give me a number with each hand. Like we could row one times column one, right? Okay, any others? Row two by column two. Any others? Row one by column two. How many others? Row two by column one. Any others? No, that's it. Okay, so we could, row one could multiply column one, row one could multiply column two. Right? There's a row and there's a column. If you got a row and a column, you can multiply them. They're all going to have the same length. Okay. And then we have row two, which could multiply column one or column two. Right? And one thing we never do is we never multiply a column of this matrix by a row of this matrix, even though the matrices are the same in this case. It's always a row, then a column. Okay. Well, that equals row one times column one. I need to read what I said. There's a plus sign there. Okay. So it's 0.9 times 0.9 added to 0.1. Sorry, 0.2 times 0.1. This and this, right? You don't have time for me to ask you, so I'm just gonna have to show you. And then we could do 0.9 times 0.2. That's a plus, not a times. Okay, 0.9 times 0.2 plus 0.2 times 0.8. Now, this is the first row times the first column. It's in the first row and the first column. First row times second column goes in the first row, second column. So where would the second row times the first column go? Would go in the second row and first column, lower left, right? So that's going to be 0.1 times 0.9 plus 0.8 times 0.1. And then we do second row, second column. That's 0.1 times 0.2 plus 0.8 times 0.8. And we do the arithmetic. That's 0.81 and 0.02. So this is 0.83. This is 0.18 and 0.16, which is 0.34. This turns out to be 0.17. You can do the arithmetic yourself, and you should be able to do it in your head because it's only single digit numbers. And this is 0.66. Now, one other thing to see about this, if you add up the columns of this matrix, you got 1. 0.9 and 0.1 is 1. 0.2 and 0.8 is 1, right? 0.83 and 0.17 is 1. 0.34 and 0.66 is 1. Okay, so for these matrices, they're called stochastic matrices. They're transition matrices. These are stochastic matrices. Anytime you take a power of one of them, you still get a stochastic matrix. And then you need to explore the idea, what if you multiply two of them? Is it still going to be stochastic? Is it still going to have columns that add up to 1? Because that's kind of an interesting thing. Now, we can't delve deeply into that. That's just kind of the beginning of something that has quite a bit of depth. But you want to see that because you might, in the future, especially like in a statistics or an economics course, you might actually encounter something like this if you take anything beyond the most basic courses. Okay? So it's kind of neat.